Hello everyone, welcome to the course Computer Networks. This is Parvathi, Assistant Professor, Department of CSIT, MLR Institute of Technology. In today's session, we are going to discussing about error correction in data link layer. In previous sessions, already we discussed about error detection. That is, error control is talking about error detection as well as the error correction. Error detection and error correction. In previous session, already we discussed about error detection, how to detect the errors at the same time, what are the different techniques are there for detecting the errors, that all we discussed in previous sessions. Now, we are going to discussing about error correction in data link layer. First, let us see the overview of today's session. So, error correction techniques. These are the error correction techniques we are going to use to correct the errors. First one is the Hamming code, and the next one we have to discuss about binary correlation codes, and next Reed-Solomon code, and finally low density parity check codes. These are the error correction techniques. Today's session we are going to discussing about Hamming code. By using Hamming code, how to correct the errors in data link layer, that is we have to see in today's session. First, what is Hamming code? Where we have to apply this Hamming code for correcting the error? First, it can apply to the data units of any length. Means the data length can be any length that we can use for correcting the errors. At the same time, it can be used to detect and correct single bit errors. It can detect the errors and it will correct the errors only single bit errors. That is the Hamming code. So, how exactly it will detect and correct the errors? First, here we will see here the sender. This is the sender, this is sender, and this is the receiver. We are sending the data in this particular communication channel. Whenever we are sending and receiving the data, first, if you want to send the data, first that will consider as here it is P plus M. What is P plus M here? M is nothing but the original data. Which data you want to send the data? That is, suppose if I want to send the data like 1011 like that, I want to send that particular data, this original message to the receiver. How exactly I am sending the data? See, with these M means number of bits original message, and I am going to add the P, that is the parity bits. I have to add that parity bits to the original data, that is the sender side. So, how I have to add, how many bits I have to add the parity bits? For that, we are using this formula, that is 2 power P is greater than or equal to P plus M plus 1. This is the formula for adding the parity bits. So, this is the original message. Whatever data, that is the original message. How many bits I have to add? I have to append to the original message. For that, we are using this formula. So, how to add the bits here? Parity bits. This suppose take this example. Here, the data size is 4 bits. Means here the data size is 4 bits. These are the 4 bits. How many parity bits are needed to transmit the data? So, here parity bits M equal to 4 here. That is the original message. So, here at the same time parity bits, how to find the parity bits? Using this formula. Suppose first I have to add only 1 bit to this particular message. This particular message I want to add only 1 bit. That time what is the formula here? 2 power P means 2 power 1 is greater than or equal to P means what? 1 plus 4 plus 1. We have to satisfy this condition. Here is 2 is greater than, P means 1 plus 4 plus 1 means here 2 is greater than 6. So, it is not satisfied. Means we can't add 1 bit. Again, if you want to add 2 bits, parity bit is 2. 2 power 2 is greater than or equal to 2 plus 4. Original bits are 4 plus 1. Total how many here? Here 2 power 2 square is equal to 4 greater than or equal to 6 plus 1. That is nothing but the 7. Here also it will not satisfy. And the next case. Next is if I want to add 3 bits. So, here if we consider 2 power 3, 2 cube is greater than or equal to, here 3 plus original bits are 4 plus 1. See total how many? 2 cube means what? 8. 8 is greater than or equal to. So, here what is this? Total 7 plus 1 total is 8. Means it will satisfy the equal to condition. So, to satisfy this condition only, that bits only you have to add to the original message. So, now I have, how many I have to add to this particular data means, so I have to add total how many bits? Parity bits equal to 3. I want to add 3 parity bits to the original data. So, that way we have to add the parity bits. So, here whatever data is sending from the sender, with these original messages, we have to add the parity bits also. Why we have to add the parity bits to the original data? For detecting the error and correcting the errors. So at the same time, this is the receiver side. What receiver will understand? Here it is two cases. None of the bits are going to be corrupted. There is no errors also. That is also one possibility. At the same time, one more possibility is any one of the p+1 bits can be corrupted. So any one of bit can be corrupted also. There is no corruption, means there is no errors. At the same time, some errors may be happen. These are the two cases in receiver side. So here, like this, we have to add the parity bits. After adding parity bits, Hamming code structure. What is the Hamming code structure? How to we have to add the bits, at the same time how we have to detect and correct the errors. So all the bit positions that are power of 2 are marked as the parity bits, where we have to add the parity bits. So we know that here parity bits, 3 parity bits are needed. For that original message 1102, we have to add extra 3 bits. That is okay. Where exactly we have to add the parity bits? Where we have to add? Where the power of 2 is there that time we have to add the parity bits. What is the power of 2 means what? 2 power 0. What is the 2 power 0 is? 1. 2 power 1, 2 power 1 means 2. 2 power 2, that is 4. 2 cube, that is 8. Where these positions 1, 2, 4, 8, that positions only we have to add the parity bits. That is the condition. At the same time, what about the remaining bits? Other bits, whatever bits after 1, 2 is completed, 3, next 5, 6, 7, all bits are allocated for the data. Like this, we have to add the parity bits to the original data. So, suppose, consider this is the 7-bit Hamming code structure. 7-bit means what? Here is 1, 2, 3, 4, 5, 6, 7. Total 7-bit Hamming code structure. So, where I have to take as a parity bit, where we have to allocate for the original data. See here, first position where we have, for whom we have to allocate, that is the parity bit, that is P1. This is first position, that's why we wrote P1. Next one, next is what? Second position also parity bit, so that we write as a P2. And next one, D3, there is no 3, only power of 2 only we have to allocate for the parity bits. So this is for data, that is D3. And next one is the fourth position, we have to allocate for the parity bits, so that it is going to be allocated to the 4, P4. Next, this 5, 6, 7, there is no 5, 6, 7, right, in this power of 2. So these 3 are allocated for the data. Like this, we have to allocate the data for the parity bits and the original data in the Hamming code structure. So till now, we know only about the how, means how many bits we have to add to the parity bits to the original data, at the same time where we have to allocate the positions to the parity bits and the original data. So how we have to determine the value of the parity bits? We know the original messages, means original message we have to send only 111011. This is we know, but exactly where we have to, means what is the value of the parity bits? Here only P1 is there, P2 is there, P4 is there. What is the value of the P1, P2, P4? For considering that, the rule is the value of the parity bits can be determined by the sequence of bits. That is alternatively checks and skips. We have to follow what we have to follow? Alternatively follows the checks and skips method we have to follow. Means for finding the P1, P2, P4, we have to use the checks and skip method. How we have to follow that method? Let us see now with an example. See here the sender is there. Here is the receiver. From sender to the receiver, we want to send the data. Which data we want to send? That is 1101. Why we are writing here 1101? See, this is the binary, right? 1s and 0s comes under the binary. Means data link layer deals with what? Frames. Data link layer dealing with frames. What frame is consisting of bits only. That's why whatever message is there, that is going to be written in the form of 0s and 1s only. That is like that the message is going to be there. So like this, we are sending the data from the sender to the receiver. So whenever the sender is sending this message, we are going to add the parity bits, right? How we have to add? So how we are adding the original data first? Here is the 1. So from here we have to write it. So here is the 1. This is the third position. Next 5, 6, 7 positions. Wherever D is there, we are allocating that place to the data. 1101. We wrote the data. And next, how we have to calculate the P1, P2, P4. So here check once we have to follow. For finding the P1, we have to follow check 1 bit, skip 1 bit. At the same time, again check one bit, skip one bit, we have to follow. So this is the position. Which position? This is the first position. First position means what? We have to check one bit. Afterwards, we have to skip one bit. Means if suppose if I checked, it is starting from the 1 only. If I checked 1 means we have to skip the 2. And we have to check the 3. Again we have to skip the 5, 4. At the same time, again we have to check the what we have to check? 5 we have to check. And next skip 6. Like that. 1 we have to check, 1 we have to skip. That we have to follow. So then it is 1, 3, 5, 7, 9, like that we have to check and skip method. For finding the P1, parity bit of 1 we have to find. And for finding the P2, how we are going to find here? Here it is talking about the second position, means we have to check the 2 bits and skip 2 bits. Again check the 2 bit, skip the 2 bits. Why it is starting from where? Second position, like that. From that second we have to check 2 means 2 and 3 we have to check. Next skip 2 bits means what? 4 and what? And 4 and 5 I have to skip. Again what we have to check? 6 and 7 we have to check. Again what we have to skip? That is 8 and 9 we have to skip. Next what we have to check? 10 and 11, like that we have to check and skip method is followed. So 2, 3 is checked, 4 and 5 is skipped, 6, 7 is checked. Next 8 and 9 is going to be skipped, and next 10 and 11 is going to be checked. Like this it is going to be considered for the finding the parity bit address of second one. And the next one for finding the P4. Or we have to find the P4, means here also same. This is the fourth position, means we have to check the 4 bits and we have to skip the 4 bits. At the same time again check the 4 bits and skip the 4 bits. Like that the process is going on. See here, it is starting from where? It is starting from the 4. From 4 onwards we have to check the 4 bits. 4, 5, 6, 7 we have to check. Then what we have to skip here? 8, 9, 10, 11 we have to skip. Again what we have to check? After 11 is what? 12, 13, 14, 15 we have to check. Like this the process is going on. See here, 4, 5, 6, 7 is checked. 8, 9, 10, 11 is going to be skipped. Next 12, 13, 14, 15 is going to be checked. Next 16, 17, 18, 9 is going to be skipped. Next 20, 21, 22, 23 is going to be checked. Means this is the fourth position. Like that we have to use this. So this can be remembered in one more way also. How we are going to in digital logic? We know that we are writing that the position of 0 means what? 0, 0, 0. And the 1 position is 0, 0, 1, 0, 1, 0, 0, 1, 1. Next one is 1, 0, 1. Like that we are going to be added, right? So this is the positions in digital logic for the position of 1 is 0, 0, 1. So based on these only we wrote these conditions for P1, P2, P4. How it is going to be? See here, where is the 1 here? After once one is going, this one is going to be checked, this is skipped, this is checked, this is skipped. Like that only for finding the P1 we wrote check 1, skip 1. That positions are 1, 3, 5, 7. Why here we wrote only 1, 3, 5, 7? We are finding the what is the total, how many bits here? It is a 7-bit Hamming code structure. That's why we are saying for only 7 bits. And the next one is the for finding the P1, what we have to say? First it is going to be, where is the 1 is going to be there? Second and third position. So here is 2, 3 is there. Next there is 0, 0 for 4 and 5. Next is 1, 1 for what? 6 and 7. That's why here it is wrote 6 and 7. Means check, to check and to skip. And at the same time for finding the P3 also, here till 3 it is going to be 0 only. From 4 onwards, so here 4, 5, 6, 7 is having the 1s. That's why we wrote the 4 check, 4 skip method. You can remember this way also. You can remember this way also for finding parity bits 1, 2, 4 like that. So coming to this one, here this is the example 1, 1, 0, 1. I have to send the data. So for finding the P1, what is the position? What is the P1 here? 1, 3, 5, 7. So here what is the 1 position is? 1 is what? Here what is here? 1, see here D3, D5. So 1 is only P1. It is over. 3, 5, 7. D3, D5, D7. For that we wrote 1, 3, 5, 7. Next for finding P2 is what here? P2 is 2. It is 2 completed. Next is what? 3, 6, 7. 3, 6, 7. 3, 6 positions are the data positions that I have taken. Next one for finding P4. Why I have to find P4 here? See here. See, P4 position means what? Here is it is P4. So for finding P4, 4 is already it is there. Next one 5, 6, 7. That we have to consider. So here the D3 position means what? D3 is 1 and next D5 is 0, D7 is 1. That is only I wrote here. So here check here P2. Here also D3, D6, D7. 3 is 1, 6 is 1, 7 is 1. That is only I wrote here. And next one for finding P4. P4 is as it is. We are going to find parity bits only, right? So D5, D6, D7 positions are D5 is 0, 1, 1. 0, 1, 1 only I wrote here. So next, how I have to find this parity? So for that already we know the concept of even parity and odd parity, right? Most of the cases we are using even parity, right? What is the even parity condition? Means if number of ones in this particular number of ones are going to be odd numbers, we have to append to 1. Number of ones are even, then we are going to append to 0. So in this case, how many number of ones are there? Only 2 ones are there. 2 means what? Even. If it is even, we are going to append with the 0. So P1 is going to be 0. And coming to P2. What is P2 here? P2, how many number of ones are there here? 3 ones are there. Here 3 ones are there. If the number of ones is odd means we have to append with the 1. So here the P2 equal to 1. And the next one is the P4. For finding P4, here the bits are 0, 1, 1. Means number of ones are 2. Means even number. So we have to append with the 0. P4 equal to 0. Like this we have to add the P1, P2, P4. So finally, already we know that these bits, this is the original message. Means we are adding the parity bits. This is the P1 equal to 0, P2 equal to 1 and P4 equal to 0. Like this the data is going to be added. This data, this is for only sender side. This data, whatever data is there, means M equal to what here? M equal to 1101. The parity bits are P1, P2, P4. That is going to be P1 is nothing but what? P1 is 0, P1 0, P2 equal to 1, P4 equal to 0. That is going to be added. With that parity bits, it is going to be sent to the receiver. Whatever data is there, that is going to be sent to the receiver. So till here only sender side is going to be completed. And next, receiver side, what is going to be happen? Receiver, what we have to check? Receiver, whether the data is going to be correct data or at the same time if any errors are there. If any errors are there, how to detect the error? If any errors are there, how to correct the errors? That is going to be happen in receiver side. That we will see now. So this is the receiver side. Here first he has to detect the error. If any errors are there or not. For that, means this is the structure, right? So here we have considered only 7-bit Hamming code structure. Here that is P1, P2. This how we allocated already. We know that the positions based on the power of 2 only we are allocating the parity bits and data bits. We are allocated. So at the receiver side it will check first. Already we know how to find the even parity. After finding all P1, P2, P4. Whatever P1, P2, P4 we find, right? P1, P2, P4. If all P1, P2, P4 are coming 0, if we go for the even parity, if after considering even parity, if all P1, P2, P4 consider as 0, then only there is no errors. Whatever we find, right, previously P1, P2, P4, if all consider all P1, P2, P4, if all zeros, then only there is no errors. If anyone, suppose in previous case what happened here, it is P1 is 0, P2 is 1, P4 is 0, means here the P2 is something what, here it is 1 means something error is there. Suppose if P2 equal to 1, P1 equal to 0, P4 equal to what, 0, means if any one is going to be 1, then there is an error. Like that it is going to be understand. So if the error is there, how the receiver going to correct the error? Means already P1, P2, P4 already knows. If means error is there means what? Sum of the position of P1, P2 are going to be 1. If all zeros means there is no error. So here for finding P1, already we find P1, P2, P4, right? For finding the P4, what we have to go? For checking the even parity only. If odd, if it is odd, error is exist. If it is even, there is no errors. This is also already we know. Then what we have to do for correcting the error? Suppose here the positions are P1. This is the P1, P2, P4. Suppose here. So here where exactly error is there? where means till here only we know there is an error. At the same time, next what we have to do here, exactly where we have to find this error, which place the error is going to be there. For that, we have to consider P1. Suppose consider P1 equal to 1 means what? Here we have to write P1, and suppose P2 equal to 1, P2 equal to 1, P4 equal to 0. Consider this is the example. These are the P1, P2 values. So, we have to find the error. Based on this only, we have to find the error. For that, we have to find the error, we find the decimal value. How to find the decimal value? 2 power 0, 2 power 1, 2 power 2. So, here is 1, 2 power 1 is 2, here is 0. Means what? Total is 3. Means third position. Whatever value is coming here, third position, the error is going to be there. Like that, we have to find. If suppose in that third position, if 0 is there, suppose this is the data. Suppose this is the 7-bit Hamming code structure. 1, 1, 0, 1. Like this, the data is going 1, 2, 3, 4, 5, 6, 7. Suppose third position error is there, I said. If the third position was 1, 2, 3, this is the third position. Means suppose here is 1 is there, right? So, we have to invert incorrect bit to correct bit. Means if 1 is there, it is going to be inverted to 0. If it is 0 is there in the third position, it is going to be inverted to 1. Like that, we have to correct the errors in data link layer by using the Hamming code. This is the process of for detecting the error, at the same time correcting the error in the data link layer. So, to understand better, we have to go for one example. Suppose here also we are considering 7-bit Hamming code structure. So, the receiver is received. What data receiver is received? That is 10111111. This data is received by the receiver. So, here receiver is going to be even parity only. We are considering there are two parities, right? Even parity and odd parity. So, we are always going to consider as a even parity. You can take any parity also. So, this is the example. We are using even parity. In the question only, they mentioned whether the received code is correct or not, we have to check. This is the receiver is received from the sender. Whether this code is correct or not, receiver is checking now. Whether we have to check the error is there or not. If wrong, locate the bit having error. Where exactly? If wrong is there, if any wrong is there, locate which position the error is there. We have to correct the error. That is the question. So, for that, what we have to do, first of all, we have to write as it is. So, this is a 7 code Hamming code structure means 1, 2, 3, 4, 5, 6. See here, I am writing 1, 0, 1, 1, 0, 1, 1. This is the structure. So, we are allocating, how we are allocating? 2 power position, 2 power 0, 2 power 1, 2 power 2 positions we are allocating for the what? Parity bits. Means 2 power 0 means what? 2 power 1 means 2, 2 power 2 means 4. 1, 2, 3, 4, 5, 6, 7. So, here which positions we are allocating for the parity? First position, this is the one. Next one, second position also. Next, fourth position, we are allocating for the parity. Remaining for the data, we are assuming, means we received this data from the sender. Whenever we are sending the data, it will along with the parity bits only, the sender is sending the messages, right? So, we are assuming. So, we are finding whether the error is there. We are detecting the error. If an error is there or not, we are going to find out. So, for that, what we have to do from these only, again we have to find the P1, P2 and P4. For finding P1 means what? P1 means what? We have to check 1, skip 1, 1, 3, 5, 7. Next, for P2, for finding P2 what? Check 2, skip 2, 2, 3, 4, 5 is going to be skipped. Next, 6, 7. For finding P4, 4, 5, 6, 7. So, 1, 3, 5, 7 positions are 1, 3, 5, 7 positions is what? 1 is 1, 3 is 0, 5 is 1, 7 is 1. So, total how many number of ones are there? Even parity I am going to check. Even parity means number of ones is going to be odd, means the P1 equal to 1. I am coming to P2, 2, 3, 6, 7. 2, 3, 6, 7 means second position is what? Already see here. 2, 3, 6, 7 position is what? 2 is nothing but the 1. And next 3 is nothing but what? 0. 6 is nothing but 0. 6 is 0 and 7 is 1. Total, we are applying even parity. Total, how many number of ones are there? Total 2 means P2 equal to what? P2 equal to what? 0. Next, 4, 5, 6, 7. 1, 1, 0, 1. Total number of ones, we are applying even parity. Total number of ones is odd means P4 equal to what? 1. So, Considering P1, P2, P4 has to be 0 only, then only there is no error. Yes, right? But here P1 equal to 1, P4 equal to 1, only P2 equal to 0, means there is an error. So, here till now we detect the error. How to correct the error? For that already we told P1, P2, P4 we have to write. P1 is what? P1 is 1, P2 equal to 0, P4 equal to 1. For this we are going to find the decimal. So, for finding the decimal, 2 power 0, 2 power 1, 2 power 2. Means what here? 2 power 0 means 1 plus 0 plus 4. Total is 5. Means fifth position there is an error. Means fifth position error is going to be there. What is the fifth position in this? Here is the fifth position. Fifth position means here what is the bit here? It is the 1. So, this is going to be inverted to the 0. Means the original message is what here? 1 0. Here I am going to change this 1 to 0, 1 0 double 1. This is the original message. This is the corrected bit. What is sender is sended, that is this one. Like this we have to detect the error as well as the correct the error using the Hamming code structure. So, coming to the summary, in today's session we discussed about error correction techniques. In that we are going to discuss about Hamming code, how to detect the error and correct the error using the Hamming code, like this one we discussed in today's topic. Thank you.